Hello, friends. Get ready for a spacey adventure from Cincinnati, Ohio. Welcome, friends, to the Cincinnati Observatory. This is a very historical building and a place I have a lot of interest in. The historical marker out front of the observatory states that Ormsby McKnight Mitchell, in 1842, with a little help, brought the world's second largest telescope to Cincinnati. Former President John Quincy Adams laid the cornerstone for this building. Friends, I am 2 hours late for my designated time for the tour, but our tour guide is on time every time. So I am waiting in this area in the middle of the observatory. I've already learned a couple really cool things. This is the birthplace of American astronomy, and I'm sure that over the course of the next hour or so, we'll learn a lot more. But already I can tell this is going to be cool. I love astronomy.
If everyone would like to join us out here in front, we're going to start the tour. Birthplace of American astronomy. Our story here starts about 1800, when settlers were coming across the mountains down the Ohio River. One family, the Mitchell family, settled in Union County, Kentucky. In 1809, Ormsby McKnight Mitchell was born. He's kind of the hero of our story here. So they lived out in the backcountry of Kentucky, western Kentucky. And when he was 2 or 3 years old, his father passed away. That wasn't sustainable for the mother to be out there with a large group of kids. So they moved to Lebanon, Ohio, where she had a married daughter who offered to help with the kids. So Ormsby basically grew up in Lebanon, Ohio. He saw an advertisement in a newspaper. The U.S. Army was looking for a few good men for West Point, New York, or the university there, for the military school. He actually applied, he was accepted, and he went there at age 15, the youngest cadet. He had no money, so he walked. He walked, he got odd jobs, he did teamster work, big teams of horses and oxen, did what he could to get there. His class was a couple people that you may have heard of: Robert E. Lee, Joseph Johnston, Confederate generals. So after he graduated, he spent a couple years teaching there, and then he decided to leave the military service and come back to Cincinnati, Ohio. So after a while of that, the City College of Cincinnati contacted him. He became a professor there, taught mathematics, taught astronomy, and then he would give speeches after class about astronomy. Could draw hundreds of people. Remember, Cincinnati wasn't that large back then. And in around early 1840s, a group of people approached him about creating the Cincinnati Astronomical Society. At that time, it cost $25 to buy one share. That was a working man's wage for a month back then. If you look at that, the names on there, several of them you may have heard of before. Judge Jacob Burnett, Burnett Woods by UC, Alphonso Taft, who was, related to President Taft. So a lot of the big movers and shakers in Cincinnati. This is John Quincy Adams. I believe he was the 6th president of the United States. Before he became president, he was Secretary of State. He was also ambassador to Russia. In Russia, the Tsar of Russia had a series of observatories. He said, that is just really cool. He said, any major country should have an observatory. In 1824, when he became president, he tried to get an observatory, a national observatory. Congress wouldn't give him any money to do that. So later, when they started building an observatory here in the 1843, who better to dedicate it than John Quincy Adams? So they asked him, he said, yes, I will come. Now remember, he was 77 years old. He came from Quincy, Massachusetts. He went up the Erie Canal to Buffalo, got on a steamship, went across to Cleveland, took the canal down to Columbus, took a carriage here. Took him 2 weeks at 77 years old. In November 1843, he came to the observatory on Mount Ida. He dedicated it, and he had a long speech, but he shortened it because it's typical November weather here. It was rainy and very cold, so he went back into town and gave the full speech later. The people were so thrilled that the former president of the United States came to Cincinnati and honored us and dedicated the observatory. They renamed Mount Ida. They said it will now be Mount Adams, and that's how it got its name. Okay, let's go in the other room. In operation 1845, this is 1848. You can see this picture is actually to such detail. If you go down to the Cincinnati Library, they have the original. They would sit there and use microscopes on this so they could read the names of the boats, the exact time the picture was taken. Very detailed picture. So the observatory, the assistant astronomers operated the observatory for several years. When Cleveland Abbey came, he was the next head astronomer. If you look through the door, you'll see there's a bust over in the corner. That was Cleveland Abbey. He came here, had similar problems, he couldn't see much. But he was also interested in the weather. He noticed that the weather west of us is what we got after a day or so. He arranged with the telegraph companies to get the actual weather and report it to him so he could actually do a weather report for the city of Cincinnati. It's the first weather report for the city of Cincinnati and one of the first in the U.S. Ultimately, he was involved in the formation and the beginning of the National Weather Service. A couple interesting things about the picture I'd like to point out. Notice the big ball up here? You know, on New Year's Eve, how you wait for the time ball to drop? We had one in the 1880s because we were the timekeeper for this part of the country. We kept the time for the railroads. Now, you know the time, there's 24 time zones in the world because 24 hours a day. Astronomers need the exact time right here, not anywhere in the next few miles. So they came up with a thing called Cincinnati Standard Time, which is the time here. If you go to a railroad schedule back then, a lot of them would show Central Standard Time, and they said to get the Cincinnati Standard Time, add 22 minutes. And if you look right over there on the wall, that's a picture of the telescope we had. It's a meridian circle telescope. That telescope really had one function, to find the address of stars. Here on Earth we have latitude and longitude, that's how we find things. In space we have a grid called declination, up, down, right extension, left, right. So they use that to determine the exact location of stars. Around 1900, the clocks they had were all mechanical. And so to make them as accurate as possible, they wanted to keep them in a place that's the most stable environment. The most stable environment in a building at that time would be in the basement. And what's behind the door? Another door. Look how thick this door is. It's filled with cork to keep the environment stable. We have a pump. I'll explain that in just a minute. Now, these are our two main clocks. You can go in them, but do not go in and touch them. That's the main clock, slave clock.
I should not expand on.
Right, because the temperature change will be very little in there because it's so well insulated. Very difficult to get anyone to work on them. The glass there is actually very, very thin, so we don't even like touching that thing. We've had several people come in and said they wouldn't touch it. This is a vacuum pump, and you just pump a little air out of there. Less air in there, less resistance, and it speeds the clock up. Conversely, if you put more air in there, it slows it down. That's how precise it was. And that's how they would keep the time. This is a 1904 Allen Clark. It's a 16-inch refractor. The lens over there is 16 inches in diameter. It's refracted. Light hits the lens. It bends the light into the shape of a cone. Down to the end of the tube, it hits a mirror. We use these eyepieces. This is what we use to actually do the magnification. So what you do, this is a 17 millimeter, that equals 371 magnification. You'll notice the axle that it sits on, it's an angle, and it's 39 degrees. It's the latitude of Cincinnati, Ohio. That angle keeps this telescope on the same axis as the Earth. So as planets rise from east, set to west, this can follow across. Look down there. That's 450 pounds of steel unmoved. If you look up here, that's the governor spinning around. Now, if you look very carefully after it goes through those gears, look at those two gears. If you look at them, you can actually see them move. Moves that axle, moves the worm gear and the other drive gear, and it spins the telescope. It does a one complete circle every 23 hours, 56 minutes, and 4 seconds. Keep this crank up, open the shutter, move the dome, and they got a quarter a night. So for instance, if you'll notice, there's actually 2 pieces of glass in there, not one.
Yeah.
You'll notice they're fairly dirty. We're not bad housekeepers. You just don't clean them any more than you need to. By cleaning them, just the act of rubbing them, you change the optics over time. The reason there's 2, you know, I said this was a refractor, you dim light. Well, different wavelengths of light dim differently. So to get all the colors at the other end where the eyepiece is, you need 2 pieces of glass to get most of the colors at the same spot, so you get a nice clear image. 2 seconds, the slave clock sent a message up here to put a little mark on here. When the astronomer saw something and they had it right in there, it was crossing this meridian, they'd press a button, it'd put another little mark on there. That way they could tell the exact time something would transit. See them? Earth. That's 93 million miles right there on this scale. And if you want to walk out there later, you'll find the rest of the planets. And we've even included Pluto. I think the important thing to understand here, so Pluto is out there, you see where the grass ends and the bushes begin? That's Pluto. If you want to go to the nearest star, Proxima Centauri, just follow that out till you get to Joplin, Missouri.
Oh.
Whoa.
Wow.
Say the last one.
Yeah. If you look right here, unfortunately I don't have my glasses on, but Fraunhofer in Munich. This was made in Munich, Bavaria, before Germany existed. This was the second largest telescope in the world when it was manufactured.
I think that they have the eyepiece in the front, right? The you told me.
Oh, yeah.
This fish patterns.
Mm-hmm.
They do.
Yeah.
But then they have to lie and
Yes.
yeah.
Oh.
Does it see?
We had a 4-inch Allen Clark on a tripod. It was actually here. Unfortunately, the janitor knocked it over and broke it. So then they got this one. This is a 4-inch Bosch and Long. Oh, okay.
do have kind of a gift shop area here, and some postcards and maps, some star maps, some of the astronomical things.
It's a Zeiss, it's a German manufacturer. This is from around 1905. Very good telescope. So we started talking to the guy, and where'd you get this telescope? Well, it was his father's. And he said, yeah, my father worked on the Hubble project. Really? Yes, he was a master optician. When they set it up and the optics were messed up initially, he was the guy who came up with how to fix. So I just think that's so amazing.
That is really cool.
And this is his telescope, and it is extremely nice telescope. And they just gave it to us.
My all-time favorite model as a kid was this. Well, friends, that was a really awesome tour. I enjoyed it quite a bit. Something I didn't tell you is that back in college, I took astronomy twice and failed it twice. I really enjoyed it though. I just wasn't very good at it. So I've always been fascinated with astronomy and the stars and what's going on with the planets. It's cool. It's totally worth the $5 admission fee to get in. Very knowledgeable tour guides, and I just liked learning a lot of this history here. It's not just science history, there's some haunted history on this property and these grounds as well. You can come and learn more about that on your own. But friends, I appreciate you joining me for this. If you like what you're seeing here, hit like and hit subscribe. Hit that bell notification button. You won't miss out on any of these adventures ever again. I'll see you in the next video, friends. Cornerstone. Very cool. Played by John Quincy Adams himself.